Okay, we've been talking about kinetic particle theory and how that relates to the different states of matter. And there are four main components to kinetic particle theory that I want you to be thinking about today, because I'm going to do a series of 3 demonstrations. And I want you to be thinking about, okay, what part or what component of the kinetic particle theory is my teacher trying to show me when she's doing these demonstrations? And on today's assignment, I'll have a document that lists the 4 components of kinetic particle theory, but we'll talk about them right now. So the first component is all matter is made up of tiny particles. And remember, those particles are your atoms and your molecules. The second component of kinetic particle theory is that the particles of matter are always moving. They have kinetic energy. The third component of kinetic particle theory is that particles have spaces between them. And the fourth component of kinetic particle theory is that adding heat to matter makes particles move faster, so it increases their kinetic energy. So again, as I'm doing the 3 demonstrations today, I want you to be thinking about which one of these components is Mrs. Van Ochten trying to show me, or is it more than one? Is it that matter is made up of tiny particles, that particles of matter are always moving and have kinetic energy, that particles have spaces between them, or that adding heat to matter makes the particles move? So in the first demonstration, all I'm going to do is add some blue food coloring to this water. And I want you to watch what happens to that blue food coloring over time, okay? And be thinking about what component of kinetic particle theory am I trying to show you? Okay, is it that all matter is made up of tiny particles? That the particles of matter are always moving? That the particles have spaces between them? Or that adding heat to matter makes the particles move faster? Okay, just by the fact that I dropped in the blue dye at the surface, and you can see what happens to that dye over time. I want you to be thinking about, how does this relate to kinetic particle theory? And be thinking about the fact that the water is made up of particles, which consists of atoms and molecules, and so is the dye, okay? Think about, is that dye just staying in where it was dropped? Is gravity taking over? Is it all going to the bottom? Or what's happening over time, and which part of kinetic particle theory am I trying to show you? Okay, for my next demonstration, I want you to notice that I have exactly 40 mils of distilled water. Distilled water is just pure water in the graduated cylinder on the left. And I have exactly 40 mils of rubbing alcohol, okay, in the graduated cylinder on the right. And I want you to be thinking about, how am I demonstrating kinetic particle theory, and which component of kinetic particle theory am I demonstrating? Again, all matter is made up of tiny particles. The particles are always moving. The particles have spaces, or that the particles move faster when they're heated. And I may be trying to show you more than one of these components, but I've got 40 mils of water and 40 mils of rubbing alcohol. Now, what you would think would happen is that if I took the 40 mils of rubbing alcohol and transferred it into the 40 mils of water, I would get 80 mils of liquid. Okay, so I'm going to back this up just to make sure you can completely see the top here. And I'm going to show you that I'm not adding any liquid or transferring any out. And I'm going to pour my rubbing alcohol right into my water. And I want to make sure that I get every last drop in there. Okay. And I want you to look. We would expect that Had we had 40 mils of water and 40 mils of rubbing alcohol, when we put them together, we'd have 80 mils. But instead, something very interesting happens. When we mix 40 plus 40, we get 75, 76, 77 mils of liquid. So 77 mils of liquid and not 80. Okay, we know from conservation of mass that matter is never created or destroyed. We didn't do a chemical reaction. These two were just mixed together to form a mixture. It was a physical combination. There were no signs of a chemical change. So no gas particles were lost in the mixture, and yet we only have 77 mils of liquid. Which part of kinetic particle theory am I trying to prove? Okay, for my last demonstration, I have 2 beakers, each with 250 mils of water. One of the beakers is at room temperature, just, kind of what came out of the faucet, a little bit cooler. One of the beakers has water that's piping hot. I heated it up on the hot plate in the classroom. So this one is boiling hot over here. Okay, this one is boiling hot. And this one is just cool, room temperature. So I'm going to put a drop of food coloring in each of these beakers, and I want you to watch what happens, and I want you to be thinking about what component of kinetic particle theory am I trying to illustrate with this demonstration. Okay, what component of kinetic particle theory am I trying to demonstrate? Okay, again, room temperature to cooler, piping hot. So think about what component of kinetic particle theory I'm trying to show.